On this video, the fourth of extra geometry circle practice, let's just look at numbers 17 and 18. These have some good things for us to think about. When I look at 17, it tells us that OJ is equal to 10. Now, I'm really compelled to put another radius in that's also 10. And because every radius in a circle is the same. But notice that this angle, the measure of angle JOK, has to be 120 degrees because the central angle is equal to its intercepted arc. And if the arc is 120, then the angle has to be 120. Now I'm going to go ahead and put a perpendicular in here from the center out. And remember that perpendicular cuts that 120 degrees in half. So this gives me a 60 here and a 60 below that I don't think I can get in writing so small. So what I've got to find here is JK. If I can find this half, I can double and get JK. So I can very obviously now use the 30, 60, 90 rule. Right angle there. I've got the hypotenuse and I need to find the long leg. So if my hypotenuse is 10, my short leg, this little piece here, has to be 5. And if my short leg is 5, then I multiply 5 by root 3 to get the long leg. But since I need to know the entire JK, then that's going to be 2 times 5 root 3. It's going to give me 10 root 3s. Let's look at something similar over here on number 18. HG is a diameter. It's creating 2 semicircles. So from H to G is 180 degrees, but 150 of those degrees are from H to F. So from F to G we know has to be 30 degrees. Okay, and that means since we have a right angle here, we've got 30 degrees. Okay, so that means that one of these little angles in here is 30 degrees. And I've got a right triangle. Now, it tells me that OE, that's going to be from O to E, right in there is 8 root 3. That is going to serve as the long leg of the triangle, one of these little triangles. Okay, so if OE is 8 root 3, and that's a long leg, to get the short leg, I need to divide the long leg by root 3. So my short leg is going to be 8. And that's going to make my hypotenuse 16. And my question is asked for HG, that's a diameter. So if a diameter is 16, an entire diameter, or excuse me, for radius is 16, an entire diameter is going to be 32. We're ready on this page to look at 4 through 9. So this is a situation where I would just ask you to please pause the video and work the first 3, 4, 5, and 6, and then watch the video to check those, and then we'll do the same thing with the last 3. So right now just pause the video and work 4, 5, and 6. Okay, you should have worked 4, 5, and 6. The directions read, tangents and chords are shown. Find the value of x and y. In exercise 5, O is the center of the circle. Okay, so as I'm looking at number 4, the one value that I'm given is this 38-degree angle. That angle is an inscribed angle. So its intercepted arc, which is the piece of the circle that falls between the sides, is the part I've zigzagged in, and it's going to be twice 38. So my intercepted arc is going to be 76 degrees. Now if you'll notice, X and Y are both inscribed angles that intercept that same arc. So when within a circle we have inscribed angles intercepting the same arc, then those angles have to be congruent to each other. So on number 4, X is also 38 degrees, and Y is 38 degrees. All right, on number 5, we have an inscribed angle out here that's inscribed in a semicircle, so we know that it's a right triangle. Looking at X, it is an inscribed angle, and its intercepted arc is 50. So that's going to make X half 50, which will be 25. And angle X and angle Y have to be complementary, because the acute angles of a right triangle have to be complementary to add up to the 90 degrees, the other 90-degree angle, so that we've got 180 in the whole triangle. So I just need to really subtract 25 degrees from 90 to find out that Y is equal to 65 degrees. And then in number 6, we have a theorem that we haven't talked about since before spring break. So we have a quadrilateral inscribed in a circle. Or we can say that the circle is circumscribed about the polygon. Well, remember, when that happens with a quadrilateral, my opposite angles are going to be supplementary. So since I have a 110-degree angle here, X has to be 70. And since I have an 85-degree angle here, Y has to be 95. Okay? It's time to pause the video again and work the last 3 problems. Okay, I hope you got the last 3. Let's look at what we've got over here for X. X, as you can see, is an arc, and I hope you can tell it means this arc there. That arc is the intercepted arc for my 60-degree inscribed angle. So if my inscribed angle is 60, my intercepted arc of X is going to be 120. Okay, but now let's look at that Y angle. That Y angle is the one that's created by a secant and a tangent at the point of tangency. So this is that special angle that, since its vertex is on the circle, we treat it like an inscribed angle, though by definition specifically it's not really an inscribed angle. But just like an inscribed angle, we're going to take half of the intercepted arc. So since my arc, my piece of my circle between the two sides of the angle is 120, then Y also has to have a degree measure of 60. Okay, I've got the message. I've got to recharge my Apple Pencil, so let me put it in for just a second while we're looking at number 8. Number 8, we have a 40-degree inscribed angle, and we have a 150-degree intercepted arc. Okay, I think that's been in long enough. Let's see if that gives us a little bit more time with my pencil. Okay, now I'm looking at this inscribed angle. And notice that the intercepted arc is 150. So I need to take half of 150, and that would give me 75 degrees for this angle. Okay? Now, that triangle that I have, the 75 and the 40 and the X has to equal 180 degrees so that there's the right amount of degrees in my triangle. So if I subtract 115 from each side, I'm going to get that x is 65 degrees. All right, now to find the y is going to be, let me change colors here. Y is half of this arc. So it would be great if we could find that arc. Well, it looks to me like that arc is also the intercepted arc for this 40. See? So since 40 is an inscribed angle that intercepts that arc that I just colored in blue, then that arc itself must be 80 degrees. And we always take half of the intercepted arc to find an angle whose vertex is on the circle. So this type of angle and this type of angle are the same type. So we get 40 degrees. Then lastly, we have another inscribed angle, and its intercepted arc is 80, so that means this angle up here is 40. We also have an isosceles triangle, so that means that x and y are going to be the same degree measure. So if I have 180 degrees in the entire triangle, and I subtract out the 40 that go up here at this vertex angle, remember in an isosceles triangle, the top angle is called the vertex angle, then I need to divide the other two angles evenly by 2, since I know they're going to be the same. So both x and y are going to have a measure of 70 degrees.